Hello, good morning, everyone. Okay, we shall start. Let's hope they will join in the meantime. If you recall, in the last class, we were discussing template functions. How do you define a template function? Using a keyword template. And you have to give a generic type name T and use it in your function. So, this max of 2 is going to accept two generic objects A and B and will return the larger of the two objects. Now we were having some problem with regard to use of string constants like this last time. So we shall see how we can rectify this. Am I audible and my screen is visible to you?
Yes, sir.
Okay.
Sir.
Yeah. Now if you run the program, I'm not getting the result as expected. Hello world. Word is a larger object in terms of the alphabetical order. We should be getting word as output. We are getting hello. That is because we are not literally comparing character by character. So this needs some amount of specialization. So the way to specialize is what we need to understand first is if I put some string in double quotes, it's a string constant. It is not a string object. Okay. Now if I convert this into string object using the string keyword here, then it will work fine for us. We shall see why this is happening. So if I just enclose the string constants inside string, we know that string is a built-in class in C++. Now, now hello and word, they are not string constants. They are now objects. So if you pass the objects to the template function as it is, it will work fine now. If you run the program, I will get the output as word. So larger of the two it is returning. So what is happening here is we are passing the objects and the objects are compared literally character by character and you will get the correct result. But if I remove this string object and just pass constant string, then it will not work for us because there is no mechanism to check character by character. It's just trying to send the string constants and it's not working for us. This requires specialization. So let's see how we do specialization here. We know that this template needs to be specialized. The first thing that you do is just say template with blank angle brackets, and the return type is now going to be a constant string, const char star, and the name of the function is max of 2 as it is, and here in angle bracket you again pass const char star because this is what is the specialization that we need to do, and mention that what is coming to max of 2 is a constant string and the two arguments are again const char star A and const char star B. Now how do I compare two const characters? I cannot say A greater than B here, so I have to use a library function string compare which will accept A and B as arguments, that is pointers to two strings, and this will return greater than 0 if first string is bigger than the next. So I just put that in a if statement, greater than 0, then I would return A, else return B. So this is the specialization that is required for the string constants to work with the template function. Now if I run the program, should work perfectly fine. So as you can see, we are getting word as the output as expected. Okay, so sometimes templates have to be specialized like this. Okay, so do you have
Sir.
any doubts here?
Yeah. Yes, sir. Actually, I am just thinking like if in the first particular template itself, T max of 2, right?
Yeah.
So instead of that, can we have something like if the particular passed particular template is string or not, and accordingly, can we just make sure that we can return A or B, meaning if it is kind of like character string, can we do the comparison over there itself instead of the again
Oh,
other template options or something
okay.
like that?
What you're trying to say is you want to find out type of A and then accordingly you want to do this string
Exactly.
comparison.
Right,
That
right.
might be a possibility, but I have not explored. Okay,
Okay.
so if there is a function to find the type of object A inside this, right?
Uh,
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 I think so. It is doable. Okay, but more cleaner and better way is do it separately, so
okay.
that you don't meddle with the objects which are already working like int, char, float.
Okay. Okay.
Okay,
Okay.
so instead of
What I
complicating the logic here, you
uh-huh.
specialize that as a separate entity here. That's a better approach. Otherwise, you
Oh,
will
okay.
mix up everything here and code becomes clumsy. Okay,
Okay.
so
Okay.
in my fair opinion, it should be possible. Like if I know type of object A, and then I will call string compare and otherwise return the second one.
Uh-huh.
Okay,
Okay,
yeah,
okay.
yeah.
What I was thinking is like, okay,
Hmm.
constant char constant.
Hmm.
Let us keep that particular function as a max of two itself.
Hmm.
Meaning, the first particular t max of two is there, right?
Yeah.
At the line number six,
Hmm.
there only we can say that okay, if that particular type is string compare, then we can call the 11th function, meaning the function at the line number 11, so
Okay.
that we are not meddling with that, but what we can do is depending on the type of the function, type of the variable what we have passed,
Hmm.
we can just do that. That is what I thought. Yeah.
No, I have not explored that, to be honest with you. Maybe
Okay.
you can try that out and I will also look at
Okay.
it. But
Okay.
more cleaner, I would say, now you don't have to worry about what is coming here, max of two string,
Right.
integer, character. I just use it just like that. Now, if I remove this and put some other data, it should work perfectly fine.
Yeah.
As before. As before, like
Okay.
if I pass 4 and 5, I will get the
Mm-hmm.
answer.
Okay.
Okay.
Okay. So in
So,
either case,
yeah,
whatever the thing is, we
yeah.
can
So,
just
see,
call that.
in C++, there is one design rule that is any class or function is open for extension, not for modification.
Okay.
If you go by that
Okay.
principle, modifying the original one is not the correct way of doing it. You can specialize it.
Okay.
Okay. So, maybe from that perspective, what we have done is correct.
Okay. Okay.
Okay.
Fine, sir. Fine.
Yeah,
Fine.
it is like
Fine.
separation of concern. Here the concern is only with respect to string constant. So
Right.
just write a separate thing here. Hmm?
Okay.
Yeah.
Okay.
Okay.
Sir, line number 10 template, it is empty, no? Can you
Yeah.
just explain that, sir?
Yeah.
Sorry, I joined late. I assumed it's afternoon.
Yeah. I mean that is a syntax. If you want to specialize anything, here you are not taking any particular type name T here. You have to use a specific type name that is const char star because you are sending two string constants. As I was telling that you are sending two string constants like this because it was not working correctly for string constants. We had to specialize. So when you are specializing, the template should be empty here. Type name should be empty. I cannot write
Okay.
the way I have done it here, type name T, because here it is particular type name that is const char star only. So the template function max of 2 is specialized only for handling string constant like hello and word which are passed here.
For any customization, const is a mandate.
No, no, no. Here, why I am using const is because I don't want this function to modify what I am passing here. Even
Okay.
if that const, it will work. You
Okay.
getting my point? Because I
Yes,
don't
yes.
see there are the two things, mutable and non-mutable. I don't want this function max of 2 to modify your string A inside its body. Even if it
Okay.
tries to do, it will not be able to do because there is a const char star.
Const. Okay.
Alright? Yeah.
Okay.
Okay. Yeah. Now coming to use of structures in templates. Last time we were discussing this. Uh, one of you wanted how to use structures in templates. I think so. Vinod raised this question. How can I use structures to modify them in the template functions? Now let's take one example. Why specialization is required in this case. All right. So is my code. Yeah. Now let's say there are two structure object, one is student, other one is employee. If you carefully observe these two structures, the member variables, some of them are common, but one or two are different. Like first two are common, like first one is string object name, here also in employee it is string name. Second is int age, and here also it is int age, but these two differ in the third one, that is one is marks, other one is salary. Now if I want to write a generic function display, okay, so let's say I want to display these two. Okay, now we have one difficulty here, that is if you want to display this structure object, if I am passing this structure object here, let's say uh, employee. In general, if I take a generic template like template type name T, and here I am going to get a reference object obj. See, whenever you want to pass any structure to any function, it should be always by reference. As I told you, it will waste a lot of space if you don't put this ampersand. Okay. So now if I try to display the parts of this object, I will be able to display name and age without any problem. For example, if I say cout obj dot name space obj dot age, but this obj being a generic, it can be either employee or student. I will not be able to write obj dot marks or obj dot salary, right? So if I write obj dot marks, then I cannot pass employee object here, because the third member is a double data type and it is salary. Okay, and if I write obj dot salary, I will not be able to pass the student object. So there is a difficulty in resolving one of the data member which is different. So this is where the specialization is required. Now with this simple template, it will work and it will display only the first two data members. It will not be able to display the third data member. So if I say student yes, and then initialize this with, let's say, Kiran and some marks here. Okay, and similarly employee E equal to Chetan and then some salary here. It's double data type. Okay.
Age.
Yeah,
Age.
yeah, age also we have to pass. Let us say age of age 18 and age of age, let's say 32. So both the
I think I think it should be first will be name and second will be 32 and then third will be salary, right?
no, if you see, yeah, second will be age. You are right.
Okay.
Yeah, this is age and this is marks, and this is age and this is, otherwise result would be absurd. 5000 age would be absurd. Okay, now if I call this display S and display E, your program will go through. I mean, it will display only first two data members of these objects. Okay, Kiran and Chetan. But the problem is we are not able to display their salary. So how do I do specialization here? Do you think specialization is required here? Okay, so we do require specialization because each object is a little different from the other. So here I define template with the angle brackets and then say write the display function. So whenever you specialize anything, after the function name you should have angle bracket and the name of the special object that you are trying to use. Let's say I want to specialize the student first. Okay, and then within the body we have student ampersand, let us say yes or whatever. You can use any variable here, and here I have to display the three different parts of the object. Yes dot name, then yes dot age, then yes dot for student it is marks, right? Then marks spelling it long. So we have done specialization of the student. Similarly, we have to do specialization of the employee. I just copy paste this. Here I have to use employee. Then employee E. Then change the variable names e dot name, e dot age, and this part alone will be different. It is going to be salary. Correct? So we require two specialization because the two structure objects are different in their member variables. So we have to do that specialization. Now without any change in the rest of it, if I just call display, the specialized template functions will be called, and you will see along with their age and name, the respective marks and other things are displayed. Okay, you are able to see this difference? Hello?
Yes, sir.
Okay.
Yes.
Yeah.
Okay.
So just try this out. I'll give you some
Uh,
5 minutes time, or
Sir, I have a
yeah,
question.
yeah,
So in the line number 15, right,
yeah,
template.
yeah,
So when you declare the 19th one is what? Specialized template, right? So
yeah,
template in angular bracket.
yeah.
So that is this will override the earlier function
No, no,
because
no,
there is
no.
three displays, right?
Yeah,
So
that's what. This original is not overridden as such. It is, rewritten in a specialized way. That's all.
but it is the program will not get confused. Like there are three
No.
displays.
Yeah,
That
there
is
are
why.
different things depending on what object is coming. Now, if student object is coming, it knows that this
Okay,
specialized
dot
thing has
is
to be. Yeah.
because of the dot.
Yeah. Now suppose you have one more structure, okay, which contains only two data members. Let's say I copy this. Then I can call the generic template function. Let us say I call it as person here, and I remove this third part. Okay. Now
Yes.
if I pass
Semicolon.
yeah, semicolon.
Semicolon.
Yeah, if I pass object of person, the generic one will be called. It will not call the specialized one. Person p equal to new, sorry, flower bucket, and then let's say we have age, right? So Sunday 43. So this person p, if I pass to display, it knows that generic template function should be called. So it will display only the first two because it contains only the first two. Okay, so though you are calling three display functions, compiler knows exactly which template function should be called. In the first case, specialized student template will be called. In the second case, specialized employee will be called. In the third case, the generic display function will be called.
Okay.
You got this?
Okay.
Would you like to try this out, or?
Yeah.
Yeah, just give a try so that you get acquainted with the syntax and clear about everything.
So in that specialized template, right?
Yeah.
You're asking that the structure type, right? What do you call that after display in angular bracket? Student.
This one.
What is that called?
No, this is you are indicating to the compiler that this display function is specialized for student.
Okay.
Otherwise, how would it know?
Okay.
Yeah,
So similarly, in your previous example, that was a const char star, right?
yeah,
So
const
you're
char star.
specifically mentioning that is for a string comparison.
Yeah, string comparison for string, constant strings.
Okay. Okay, sir.
So first create these two string objects or these three string objects. Create one, copy paste and make the changes. Yeah, the next thing to learn in C++ is called as functors. And the spelling is a little funny. Functors stands for function objects. Now we shall see the utility of this concept and how it is useful and why this feature was there and how it is replaced later by lambda functions, right? Now functors are nothing but functional objects, right? Now we'll take one application scenario and see how that can be used to demonstrate the use of functors. So I have already done it here. First thing is you have to create a structure of some product like this, and normally let's say you want to apply discount on these product prices in different ways. That can be done through the functors. Now the way this works is, let's say we have a structured product with two data members, name and price. Now I need to define a functor. The way functors are defined is either using a class or a structure. We prefer using structures because inside structure everything is public. So let's say we define a functor here, struct fixed discount, where you give some fixed amount of discount, and here as a data member, let's say discount amount. And just like a class, a structure can have a constructor. So this fixed discount will accept discount amount, and you can initialize using inline initialization, just as the way we do it in a class. Okay. Now we should write a functor inside this. The way it works is, every functor will have a return type including void. Now let us say after the discount we want to know the actual price. So return type here will be float, and you should use the keyword operator and put a bracket like this, opening closing bracket, and this will accept the amount on which, or the price on which the discount should work. Within the body of this you just say return price minus discount amount. Okay. Now this is a structure object which contains a data member. It's initialized through its constructor, and there is a special function with the keyword operator. It has to be operator. This is a reserved word, operator opening bracket, and then what this operator takes as an argument should be of certain type. Since we are working with real numbers, it should be float, and we are just doing some computation here. So the way it works is, we create first one product equal to, let's say product name is mobile, and the price is some 9,000. Is it float or double? Let's say it's float, yeah. Okay. And we have to create one functor here using the name of the structure that I use here, fixed discount. So I say fixed discount. You can give some name, FD, and pass as argument how much discount you want to give. Let's say I want to give 500 rupees discount. Okay, so this is expecting a real number, so I'll pass F like this. Okay, now if I want to act on this product P, then cout product P dot name, and here just say price after discount, like this, and you call the functor with what is the price that you have for the product. So what this functor does, it will act on the price of the object and then give what discount you get after the discount is applied. If I run the program, right, product pages. Oh, I have given system CLS at the end. Just 1 minute. Now you see that the product name will be displayed along with what is the actual price. So product is mobile, price after discount is 8,500. So we had 9,000 here and we have applied 5,000 rupee discount. Okay, so the functor is nothing but a structure containing one operator that acts on the object that is passed to it. Okay. Similarly, we can have one more functor where I give percentage discount, and you can specify percentage discount or discount percentage. We will maintain this discount percentage. Here again I have to initialize the percentage discount. Discount percentage and discount percentage bracket dp. So this will initialize the member variable of the structure, and then you say float operator opening bracket, then float price, and within the body, since it is a percentage discount, now the computation here will be different. It will not be price minus discount percentage. It will be price minus price into discount percentage divided by 100. Right. So as you can see, this new functor has a different logic to compute the discount amount. Alright, so we have to end the structure here. Again, we can define a different discount object. This will be percentage discount PD, and here you can mention the discount, let's say 10%, and copy paste the same, but this time applying a different functor on the product name. This will be PD price. So what should happen? It will give 10% discount, that is on 9,000 if you do 10% it will be 90 rupees. So the result will be some 8,100. Okay, 8,100 is the output. Okay, yeah. So any doubts here?
So that what was this functors were used?
Yeah, I mean, see, I want to act on certain data objects in a certain way, right? So here you have the option of operating on the product price, right? So one functor is giving you discount with a fixed amount. Okay, another functor is giving discount with respect to percentage. Now this is a kind of thing available before lambdas were introduced, right? The same thing can be done using lambda functions. Okay.
This acts only on a structure
Yeah.
object.
No, you can use class also here. You can define a class. Okay, Instead of a
Okay.
struct, you can use a class. But struct, because everything is public, I don't have to write public because everything has to be public here. Okay,
Okay.
so we are not bothered about protecting the data members and all that. Just use this operator thing to act on the object value that is passed here.
Okay.
Yeah.
Sir, so it is like if you want to modify only one of the argument in that struct, then we use this.
Yeah.
Uh,
Yeah,
okay.
now if you want to modify both like name and price also, you can pass the object only here. So instead of price, I can pass the object like product P,
Oh, okay.
but you have to pass the reference there.
Correct. Correct.
Then you have to say P dot price.
Price. Correct. All of that will come.
This is also fine,
Okay.
isn't it?
Okay.
But while passing here, while invoking, you have to pass the object P, not P dot price. Okay, so now also should work. Okay, and here we have the freedom of modifying the product name also, right? Let's say P dot name equal to, instead of mobile, if I change it to, let's say, some laptop, that gets changed, isn't it?
Okay.
Let's see if that gets, of course it gets modified and it gets reflected here. Product laptop will come now, right?
Correct.
Yeah, so all those variations are possible.
Okay. Thank you.
So just give a try and get yourself acquainted with this concept.
So this function name operator is system defined or like we can change it?
Which one?
Operator.
No, this is compiler defined operator. You have to use operators here.
Set
Yeah, class which will act as a functor.
Okay. So
Now whole
right, there is
whole structure
particular
variable is called functor. Okay, so because you are creating one object, no, fixed deposit is a structure variable. FD is a structure variable. This structure variable FD is called functor, and functor definition which you do here contains one member variable, member function, which is called as operator.
Okay.
Okay, just give a try. Just get acquainted with the syntax and